Hey there, Algebra 2A. Welcome back to the second installment of Lesson 24, where we are going to continue to look at solving systems by using elimination. So something we talked about back in day one was that we need to write each of our systems in standard form. So we'll take both these systems. This top one is already in standard form. Here I'm going to have to subtract 6y over to get it into standard form. So right now I'm going to rewrite both systems in standard form. So we take a look, and remember, we're looking for any variables that have the exact same coefficient. So we can either add or subtract to eliminate them. Well, here we don't have that case, but if we do look at the x's, we have a -3, +9. I like that first because it's a negative and a positive, so we can add to cancel to get to 0. And we need to also multiply that top equation so that it matches a 9. So if you have a -3, you're thinking, what could you multiply -3 by to make it -9? And if you're thinking 3, then you are correct. So I'm going to take that top equation, multiply everything by 3, so that I can get the x's to be a -9, and then I already have that +9. So what I did was now got the x's so that they can cancel. So a -9x and a +9x will add to make 0x. Then a +6x plus +6y plus -6y is going to be a 0y. Ooh, something interesting is happening here. And then 15 plus -15 is also going to be 0. So basically what I get is 0 is equal to 0. So what we did was we had added two of the exact same lines, and we get this true statement at the end, which means that we are going to have infinite solutions. So this one is going to be classified as dependent. So going back to when we talked about this with graphing in lesson 15, whenever you have two of the exact same line, they're always going to be intersecting or always going to be touching each other. So that's going to mean that they have infinite solutions, which is a dependent system. So checking out B, I've already put both into standard form, so I just had to take the top equation, subtract 3y over. And again, you're looking to get your variables to be the exact same coefficients so that you can cancel out. So up here, if I multiply this one by 3, that's going to make a 12x and a 12x, and then I can eliminate the x's. Once I've got the 12x and 12x, to cancel those, I'm going to subtract 12 minus 12 is 0, so that's going to give me 0x. Then I go -9 minus the -9, which is like -9 plus -9, which also is going to be 0. So here we have a special case again, 0x plus 0y. 21 minus 15 is going to give me 6. So this one says 0 is equal to 6. Which, is that a true statement? No, that is false. That's a false statement. So this one is going to be two different lines that have the exact same slope, which is going to be parallels, which are inconsistent systems. So they have no solution. They're never going to touch each other. So we call that one inconsistent. So in example 3, we look at a couple special cases where your variables will cancel out. We're still using the same methods as yesterday, trying to find a variable to cancel, but then we see both canceled, and then we start to see those special cases. To finish up lesson 24, day 2, we'll take a look at a story problem. So example 4, Tamara and her sister bought school supplies. Tamara bought 5 spiral notebooks and 6 book covers for $10.75. Her sister bought 4 spiral notebooks and 5 book covers for $8.75. Find the cost for each spiral notebook cover. Whenever I'm doing a story problem, I always look at this last sentence. And the first thing I'm going to do is identify the variable. And what we're trying to find is going to be the variable. That's going to be the unknown. So X, we could say, is going to be the cost of the spiral notebook. And furthermore, Y then is the cost of each book cover. Next, we can look at the amount that each girl bought, and we can start to develop a cost equation for the amount of notebooks and book covers they cost and the total cost. So first, Tamara bought 5 notebooks and 6 book covers for $10.75. So we're going to take 5 times the cost of the notebook plus 6 times the cost of the book cover, which we still don't know yet, and that's going to equal $10.75. And then her sister, she bought 4 notebooks at a certain cost plus 5 book covers at a certain cost, and that's going to equal $8.75. So each of their stats are now transformed into an equation, and now we're ready to use elimination to solve. So taking a quick glance at all of our variables, we do not have any variables that have the exact same coefficient, so we're going to need to manipulate them a little bit by multiplying. So 5x and 4x, I'm going to look to try to cancel the x's. Now 5 and 4, there's no way I can multiply 5 to make 4 or anything like that, but I can look at how they meet at 20. So I'm going to multiply this top equation by 4. That's going to end up making that 20x. I'm going to multiply this bottom equation by 5. That's going to make that also a 20x. So next thing I'll do is I'll take 4, multiply each term in my top equation. I'll take 5, multiply each term in my bottom equation. And I'm going to write a new system of equations where I'm going to have a 20x and a 20x so that I can eliminate the x. So now by taking the top equation, multiplying it by 4, the bottom equation, multiplying it by 5, I've made my x's both 20. Now I'm going to subtract everything in the bottom equation. So 20 minus 20, that's what I wanted to eliminate, 0x. 24 minus 25 is going to be negative 1y. 43 minus 43.75 is going to be negative 75 cents. So that tells me, divide both sides by negative 1, that my y is going to equal 75 cents. So thinking back to our situation, that's the cost of each book cover. Now we can pick an equation, and I'm going to use one of these original ones because they're a little bit smaller numbers. I'll take the sister's equation, and we're going to find x. So we'll take 4x plus 5 times 75 cents, and set that equal to 875, and then we'll solve for x. And that's going to tell us the cost of each notebook. And when we substitute that y back in, we can find the cost of the notebook, which is going to be $1.25. So then my XY pair I put way off to the left there is going to be $1.25 and 75 cents. So there we had to multiply both equations. That was the first time we had to do that in day 1 or day 2, but that is possible that if you need to get your variables to get that same coefficient, you're going to want to multiply both top and bottom to get that to eliminate. So in lesson 24, we're wrapping that up. We have learned our third way to solve systems of equations using the elimination. Thanks for joining, and we'll see you next time.